Hi, everybody. Welcome and thanks for being here. This video is going to take you through lesson 2.3. This lesson has 5 parts in Amplify. Inside here, you'll see the video that you're watching. There's that link. Thanks for watching it. Don't forget to like, share, subscribe, comment, all that good stuff. Also, you'll find your login to Amplify. But before we do that, guys, let's check out these key concepts. So, we have our driving question for our whole unit of study and how does light interact with materials. In chapter 1, we started to learn that certain types of light from the sun can damage our skin and cause cancer. And we're still investigating that key question, and that is, how can the same amount of sunlight cause different rates of skin cancer? For our lesson today, friends, we're going to be seeing how different kinds of light can cause photosynthesis. So, in our last lesson, we covered this key concept and that there are those different types of light that can change material in different ways. And today we're going to be covering some new key concepts, and that is a light source can emit more than one type of light. Also, different types of light have different wavelengths, and we're going to be learning a little bit more about wavelengths today. So those are our driving questions and our key concepts. Let's go ahead and begin this lesson. You'll see there's written instructions here, but it's really beneficial if you just follow along in this video and complete the activities as I show them to you. So first things first, we're going to log in. Maybe. Boom, there it is. And let's move my face out of the way. Okay. So for this one, guys, we're going to look at a diagram here. And it's the same one from the article you read during the last class, Harvesting Sunlight. And what we're going to look at here is we're going to notice that, again, going back to our key concept, different kinds of light emit different types of light. Now we can see here we've got the sun, and these are all the different spectra of light: radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and of course those gamma rays. And our visible light makes up all these colors here. And we can see that the sun is providing all of these, while our grow bulb is only providing the visible spectrum along with infrared, which makes things warm, right? So the sun emits all types of light. A grow bulb is designed to emit a lot of types that plants need for growth and very little of the types that plants don't need. So what I'd like you to do is answer this question based on your understanding of what's happening in this diagram. So how is light from a globe? Let's start over, Roberts. How is light from a grow bulb different from light from the sun? Use the information in the diagram to explain. I will go ahead and pause this and let you answer this question. So hopefully you've already responded, and your response looks a little something like Mr. Roberts here. A grow bulb and the sun emit different types of light. A grow bulb only emits visible light and infrared light, while the sun emits those types of lights and every other type. Nice. So we're done there. Let's go on to part 2. So it will eventually load. There it is. So this article is an article you've already read, Harvesting Sunlight. It would be good to kind of go back through, maybe do a speed read, just like your body needs energy, and we get that from eating food, breathing, drinking water, all that good stuff. Plants need the same thing. They actually use sunlight as their energy source to drive that mechanism called photosynthesis. So I will let you reread this really quickly. Some of the key things to think about, though, are, if light is being absorbed by a material, then it's causing that material to change. So what I want you to do is reread this article just real quickly so you can kind of get the wheels spinning. And what I want you to do is, as you're rereading, I want you to keep in mind, do plants absorb all types of light? I want you to answer that question. What is one type of light that can be used for photosynthesis? Okay, so again, we're using that information from the diagram in our reading to answer that question. And which type of light causes damage to plants? So let's go ahead and answer those questions. Go ahead and pause the video, do your reading, and push play when you're all done. All right, friends, thanks for meeting me back on the other side of your work. So hopefully your answers look something like mine. Do plants absorb all types of light? No, they do not. What is one type of light that is used for photosynthesis? For this one, with this drop down, you can just look at this plant here and choose any color. I chose green. What is it? Which type of light causes damage to plants? We could choose ultraviolet, but as we're going to see in a moment, when we actually start experimenting with these concepts in the next part in our sim, gamma rays and x-rays can damage those plants as well. Make sure you push your little hand in button, and let's go to part 3. Okay, so for this, we are going to dive in deeper to our sim, and we're gonna start to learn a little bit about this idea that light travels in waves. We have things like amplitude, and we have wavelength, and those things change the characteristics of light or the wave form. So for this one, it does say, hey, you're gonna have a partner A and a partner B. Obviously, in this model, we're not doing that, so you can choose to either be partner A or partner B, and I'll do a little bit of both in this video with you. Bottom line is, if you follow these steps, you'll be good to go. So it says click here. That's going to open up the sim. Choose custom light source, then edit wave, and then adjust the amplitude by dragging the arrows, and notice how the light waves change. Adjust the wavelength by dragging the horizontal left and right. So for my friends who really hate following step-by-step instructions and just like looking at pictures, just watch me. Okay, so I believe the first thing it said was, hey, we need to make this be a custom wave. And we are gonna, oh, rats, I already forgot the next step. Custom edit wave. Yes, edit my wave. That's what I want to do. All right, friends. So here's what we have. This is our light creating tool where you can customize your own light waves, and you can see how tweaking them and changing them treats different kinds of light. So right now we have a wavelength established. 1 times 10 to the minus 14 meters. Holy cow. That's about the size of an atomic nucleus. Actually, let me get this here. Now we have some other data that's here. Like right now, it's telling us the wavelength, which is related to the frequency. We also have, we also see that the intensity is rather high, and that the type of light that this is emitting is gamma ray. Now watch, as I slide this slider out and I make the waves a little wider, see how it's a little further apart? And now it's the size of an entire atom. The intensity is still high, but look, the type of light has completely changed from gamma ray to X-ray. And we can continue to do that with all of the different wavelengths. So now we can create ultraviolet light, which is the size of a virus, or violet light, just like the violet light that we can see, that purple color. And we can keep on going through the visual spectrum of light. And then eventually we will get to infrared. So those wavelengths are about the size of a red blood cell, and we're in infrared. And we can go all the way out to microwave and, of course, to radio wave and see the changes occur. The other thing besides the wavelength is, and I skipped this one because it's just not as much fun, is the amplitude. Okay, so here's my radio wave, You can see it's this big, long radio wave. It's about the same length as a bridge. Now, its intensity is really high. Let's see what happens when I change the amplitude. So my amplitude just changed. My wavelength and my frequency stay the same. But what's happening is the intensity is going down. It's medium. And if I change that amplitude all the way down to here, now the intensity is at low. So again, light carries energy. Light waves that have a smaller amplitude have a lower intensity or a lower amount of energy. Okay, so that was fun playing with that. Let's dive back into our tasks. So we need to create a type of light that will cause a plant to photosynthesize and create a type of light that will cause it to be damaged. When you go through to answer, you can answer for either one, but here's what I'm going to do right now. I need to create a type of light wave that will cause photosynthesis and damage. So I'm going to go all the way up to my highest amplitude, and the first thing I want to do, I don't know why, I guess I'm just that kid that likes to knock down the blocks. I'm going to go for the damage one. So I want my amplitude cranked up, and let's see if we can find. So before we said ultraviolet can cause damage to the plant. Let's go ahead and test that idea. So what I do is I hit confirm over here, and that means this light now, when I turn it on, it is shooting a beam of ultraviolet light. Now I can take my little plant, put him there, and I can inspect, see what's up. Oh my gosh, totally damaging it. High amount of damage. Yay, success. But let's do this. Let's keep going. Let's see, will X-ray cause the damage? Let's see. X-ray, inspect, yes. So we know X-rays will cause damage. Let's do it again. Let's go to those gamma rays, those really high energy waves, those really short, small wavelength waves. Let's confirm. We can see we've got those gamma rays now. When we inspect our little plant, we see we have a high amount of damage. Okay, so now let's do it in reverse, but let's stop being mean. And let's find a wavelength that will cause photosynthesis. So we kind of already know where to start because we've seen all these other ones cause damage. But here's our visible light on one end of the spectrum. Let's inspect. A high level of photosynthesis is occurring. Yay! Now what I want to do, because I know these other wavelengths of light will cause photosynthesis, I want to get all the way out to red, and then I want to get to infrared. And let's try that. Now, what do we have here? We've got infrared light, and no photosynthesis is occurring, only warmth. So we know that, we know that infrared light will not work, and we just need, we need something in the visible spectrum if we want to actually cause photosynthesis to happen. So we've collected some data now from running those sims. So now you need to answer these questions. Changing amplitude causes the light to change type or wavelength. So again, go back to your sim if you're not sure and practice. We already have a type of light. If I change the amplitude, does that change the type of light? I'm going to say no. If I change the wavelength, does that change the type of light that I'm looking at? Let's try it. So I'm looking at infrared light. I'm going to make this wavelength a little different. So as I change the wavelength, you can see in the lower corner right here that that type of light is changing as I'm changing the wavelength. So we know the answer, right? Wavelength. What type of light did you make? If you made a type of light, enter it in here. It should match up though here. So whether you chose green, whether you're shooting for damage or growth, you're going to want to make sure that both of these answers make sense. So I'm going to just say gamma ray. I'm going to say damage. And hit save and continue. Some keywords we need to go over real quick. Wave is a pattern that describes how energy is carried from one place to another. Okay. That could be a wave on the ocean, right? That could be a sound wave. That could be a light wave. And light is a type of wave that carries energy from one place to another through empty space. And now that we've done our sim investigation, we're going to watch this brief video together. Yay! So let's take a moment together to kind of break this down. So we've been learning about wavelength, and with light waves, wavelength will change the type of light that we're working with. And that's basically it, friends. So looking at this, you can see the wavelength is kind of packed together. Well, this one's more spread apart. So in my mind, I'm thinking as far as our spectrum goes, this is closer to the X-ray, gamma ray side of things. And this is closer to the radio microwave side of things, where the wavelengths are stretched out versus smushed together. Let's go to this section and break this down even further. So we have these two, let's see if I can make this all fit in there for you. Okay, we have these two models here, and your job is to look at these models and try to figure out which waveform would describe the light emitted from light source 2. So looking at this, we can see light source number 1, and we see the light traveling along. It's being absorbed by whatever this is. I'm calling it a roll of toilet paper, and it's creating warmth. Okay, and we can kind of see the pattern of the wavelength here. right here, we've got this little pattern of our wavelength. So we kind of know what type of light that is. Now we need to find a light source. That's why we have this question mark. We need to find a light source that's going to cause damage to our little roll of toilet paper. So I'm going to let you really think about it and make your decision. Go ahead and pause the video. Okay, so hopefully you've had a moment to think about this. And hopefully you're starting to see a pattern where if our wavelengths are the same, that means it's the same kind of light. So is there one down here that's the same? Absolutely. C is the same, but we don't want to create warmth. We want to create damage. So we know it's not C, so now we have to either choose A or B. So we've eliminated at least one. Now, if we can actually go back to our sim and we can kind of start to notice that, remember when we shrunk these wavelengths down, especially to X-ray and gamma ray and ultraviolet, that's when the damage really started to happen with the plants. So if we do the opposite of that and we go all the way out here where we get to radio waves, we're being bombarded all the time with radio waves. That's not causing damage. So we've kind of seen a trend where as these wavelengths get smaller and tighter together, we see more energetic light and we see more damage being caused by it. So I'm going to try to look at these two choices. Which one of these is closer to the X-ray, ultraviolet, gamma ray side of things? And the choice is A. So I'm really hoping that you guys pushed A and pushed that hand in button. And we will move on to part 5, which is our final part of this lesson. So for this one, my friends, you're going to read about why no one can hear you scream in space. So this is our article. I just want to remind you, you can have the article read to you if you wish. And I just have to tell you guys, as you read this, just know that it's not entirely 100% correct. Everybody says space is a vacuum. It is definitely not a vacuum. There are particles out there. And yes, sound can theoretically travel through space, just not very, very well. But anyway, I'd like you to read this article and answer these 3 questions. Why can't sound waves travel through space? What are things that sound waves can travel through? And can light waves travel through space? And explain. So go ahead and pause the video. I'll let you answer those questions. Unpause when you're done. All right, friends. Hey, I'd like to share my answers with you, see how yours match up with mine. So why can't sound waves travel through space? Well, they can't travel through space because they need something to travel through. And in space, there is no air or no other matter for them to travel through, even though there kind of is. But we won't talk about that in 8th grade. We'll learn about that in high school and in college. What are things that sound waves can travel through? Sound waves can travel through molecules in the air. They also travel through a solid or a liquid. So they just need molecules to bump into one another. Can light waves travel through space? Yes, light waves can travel through space. Electromagnetic waves do not need any matter to travel through. Friends, please push that hand in button. Don't forget to like, share, comment, subscribe. Be good people. And thanks for being here with me.